Your synapses are processing moments slower than you think. Imagine your brain naturally smoothing out time itself, not by choice, but through altered electrical rhythms inside deep pathways like the pyramidal tract. It's almost like a biological slow-motion machine engaging when we go quiet enough for introspection. This slowing down of internal signals changes how fast reality seems to pass us by. We call these subtle shifts in firing kinetics evidence of natural system stabilization, a way our biology engineers profound stillness without ever trying.
What emerges when these internal rates slow is a completely different kind of flow. Think of an ocean current suddenly finding its deep, stable rhythm after tossing wildly on the surface. That shift reflects how our basic sensory intake starts filtering through this calmer substrate reality. Researchers are tracking precisely how input velocity changes within those primary pathways. It suggests that stillness isn't passive, it's a highly efficient mechanism for regulating everything else we experience. This stabilization has observable connections to deeper patterns of awareness itself.
Imagine that even when our systems are quiet, information keeps flowing in a subtle way. This isn't just steady operation. This is how deep internal processing naturally dampens down its own speed, like an old vinyl slowing right before the perfect final note fades out. We see evidence of these shifts not in conscious choice, but in how electrical signals propagate along those vital brain tracts. It means that our capacity for stillness isn't just about stopping. It's this slow-wave integration itself acting as a massive system stabilizer across all neural structures, which means something nobody expected. For understanding why some states feel utterly unbound from clock time, the resonance we see emerging when the internal rhythm shifts to slower modes is fundamentally altering how brain networks communicate with each other, building up an entirely new kind of awareness that defies simple definitions.
Now consider what that systemic slowing does when you zoom out past individual signals. We see this profound shift in synchronization patterns across widely separated brain regions. Think of a massive orchestra suddenly coordinating through an almost imperceptible deep harmonic hum rather than sharp solo lines. Everything flows together smoothly instead. This echoes findings suggesting how our innate drive for stability actually dictates the velocity of information transfer itself. But there is resistance to this idea. Some models argue that these temporal dampings are merely noise reduction and not a genuine substrate reorganization at all. What does it take to move from stabilization to actual systemic transformation? You need to witness what happens next. The slowing process goes deeper than just quiet reception. It touches how our fundamental input pathways behave when these slow dynamics are sustained. Imagine tuning an antique radio until you catch that perfect, unbelievably clear, deep frequency. That's what we're observing in neural firing kinetics within the pyramidal tract. The inherent tendency of this system is to naturally smooth out information throughput just to maintain its foundational stability. But here is where it gets strange, because stabilization alone doesn't explain subjective time shifts. That same dampening mechanism, which we know regulates network flow, also governs how our primary biological hardware processes what hits the gates first. It's a direct modulation of sensory reception velocity itself. And what happens when that deep, inherent slowing, that biological smoothing out of incoming signals across those initial pathways, meets external experience? It becomes something else entirely. The system isn't just dampening noise, there's a deeper resonance emerging between these internal slow waves and the wider connectivity of your awareness itself. Imagine catching an echo in a vast canyon, not one sharp reflection, but a sustained, unified harmonic chord that seems to hold reality captive for a beat longer than physics allows. It hints at something profoundly non-linear happening beneath everything we recognize as thought. And if this subtle shift can fundamentally rewire how distant brain structures speak across the cortex, then what exactly is it building toward?
The core finding is that deep stability isn't just quiet and actively dictates how fast your perception moves.
Think of a massive, finely tuned clock whose gears naturally slow down during long periods of absolute zero movement. That inherent tendency towards slower information throughput within those primary tracts keeps the system regulated from collapse. It proves these internal rate shifts are our body's sophisticated insurance policy against systemic runaway excitation. The takeaway is this: true self-awareness isn't found by fighting the rush, but by observing the deep current that naturally resists it. That intrinsic regulation offers a map to profound stillness without any conscious effort on your part. The full research archive is at jmthomasofficial.com. What emerges from that intrinsic resistance is a framework mapping how natural system stabilization directly shapes awareness itself. Think of calibrating ancient cartography. You need slow, stable reference points before any distant feature can even be charted accurately on your map. That steady drift in baseline excitability provides the bedrock for what we call network resonance, allowing signals to flow smoothly across disparate structures. The actionable truth here is recognizing that this endogenous slowing isn't just maintenance mode, it is a foundational blueprint for sustained self-reference. It gives us a way to measure integration without needing external stimulation at all. The full research archive is at jmthomasofficial.com.